Geometric sequences. A sequence is geometric if each term can be found by multiplying the previous term by a non-zero constant. We're multiplying now. Technically, we're also dividing, but actually, because if we were dividing by 2 each time, what is that equivalent to with multiplication? Timesing by a half. Yeah, exactly. So we try to focus on the multiplying as opposed to dividing. Is everyone okay? You'll see in a second. So examples of geometric sequences: 4, 8, 16, 32. What's happening each time? Not going up by 2. Multiplying by 2. You have to be careful how you say it. Multiply, because if you said in an exam going up by 2, you get it wrong. Okay? Times by 2. So I just want to write that down. It's timesing by 2. Okay. What about the next one? What are we timesing by? If you're not sure, you can say what you're dividing by. Roxy?
Timesing by a half.
You're timesing by a half. So let's write that down. I'm timesing by a half. Timesing by a half. Timesing by a half. Okay, so we're always focused on what we're timesing by. Okay, now, this thing we're timesing by everything, this is called the common ratio, or R. So for up here, the common ratio, you know how before with arithmetic series we had common difference?
Yeah.
My head's gone blank. Common difference. This time we have a common ratio. Is that okay? In the first one, the example is common ratio, which is 2. Because why do you think it's called common ratio? Last time it was difference, because we subtracted. This time it's called ratio because why? Alicia?
It's because, say, 4 and 8 has the same.
4 to 8 is 1 to 2. Another way, what's another way to write a ratio technically? Without the dot dot. A fraction. Technically, girls, a ratio can also be written as a fraction. And if I wrote U2 over U1, that would be 8 over 4. Is that correct? And is that 2? Yeah. Same with U3 over U2, 16 on 8. That's 2. 32 on 16. That's 2. Is everyone okay? What about for B? Just by what we already wrote, what is the common ratio? Oh, sorry, this is R. What is the common ratio in B? 1 over 2 or a half, yes? Or 0.5, either one would be correct. How could I have worked that out from the numbers in the sequence? Rhiannon?
I want to say so for example, U1 divided by U2.
Other way around.
U1 divided.
Other way around.
Yeah,
U2.
divided by U1.
Yeah, you said U1. Okay, so it would be in this case 10 over 20, which is a half. Or 5 over 10, which is a half. Or 2.5 over 5, which is a half. Is everyone okay?
Yeah.
All right, so here's the definition. UN, again, with those curly brackets say it's a sequence. The sequence of UN is geometric. Then R is UN plus 1 over UN. In other words, that equals any term divided by the previous term. So instead of minusing like last time with arithmetic, we're dividing. That's the difference. Is everyone okay? Any term divided by the previous term. Not the next term, the previous, the one before. Everyone okay? And that's what we did in our examples, isn't it? Beautiful. Okay, where R is called the common ratio. And it's common because it should work for every pair. Every pair in the sequence, otherwise it won't be a geometric sequence. All right. The general term. For a geometric series, I should have said sequence. With first term U1, why should I have said sequence? Technically it's true for series, but why should I have said sequence at the moment? Yeah, it's a list of numbers and that's what we're focusing on. We're focusing on sequence. We're actually not up to series. So I should have said that sequence, sorry. with first term U1 and common ratio R, the general term of the nth term is given by, UN equals U1 times R to the n minus 1. Let's think about that for a second, okay? So if the first term is U1, the second term is U2, but how could you write that in terms of R and U1? What would you do to U1 to find U2? Think about it, hands up, good. What would you do to U1 to find U2? If it helps, look at our previous examples. What would you do to U1 to find U2? Sabine?
Times it by R.
Times it by R. That's what happened in this first example, isn't it? Sorry, give me a second. Up here, we're timesing by 2, or in other words, R. So, let me explain again. So, if we're timesing it by R, what's U2?
U1 times R.
U1 times R. Can I write that like this? Is that okay? Or maybe I should have written it more like the rule, which is U1R. Is that okay?
Yeah.
Sorry. What would the next one be then? What would, hands up, think about it. What would the next one be, Alyssa?
U1 2.
Close. You're timesing. What's R times R? R squared. U1, oops, let me try that again. U1R squared. What would the next one be? Beautiful. What would the next one be? Give me one more. 4. Beautiful. So girls, this is, well, obviously U1. This is U2. This is U3. This is U4. This is U5. Everyone with me? Cool. So what is N here? What is N for the first one? It's really simple. It's not a trick. 1.
Or 1.
What is N for the second one?
2.
What is N for the third one? What is it for the fourth one? It's really simple. Beautiful, beautiful, beautiful. Now, look at all these that we've written and look at the rule. Can you now explain why the rule is what it is? Have a think. Look at everything we've written and then compare it to the rule. Put it this way. Basically, you can see them all are in terms of U1 times R to the something. U1 times R to the something. Why is it n minus 1? Why is the power n minus 1 instead of just like n? Rhiannon?
Is it because U1 isn't times by R? Does that make sense?
Mm-hmm. U1 is timesing by R.
No,
Oh.
U1, you don't times it by R.
So what invisible power of R is actually there? 0.
Which equals 1.
Which equals 1. Yes.
It's just U1.
Yes, exactly. Girls, basically I was just going to say it's n minus 1 is the power.
Yeah.
But the reason for that is because U1 doesn't have any R, or in other words, R to the 0. Is everyone okay? So that's why we're minusing 1 from the power. Sorry. Everyone okay? Let's try a question. Consider the sequence 9, 3, 1, blah, blah, blah. And girls, remind me, why do we have to at least write 3 terms when we write down a sequence? Hands up. Why is that? Roxy?
You can't find out like the rule without the third one. 2 doesn't determine if it goes along with others.
Yes. And it helps you find the common ratio or difference or whatever it is to check that it's the same between both pairs. Beautiful. Okay, so for A, what does it say? Show that the sequence is geometric, which is similar to what we used to do to show that the sequence is arithmetic. What do I need to do? Have a think. Good. Tegan?
Like show that the common ratio applies.
Exactly. So what's one pair? What should I do?
3 over 9.
Beautiful. 3 over 9. And what is that simplified to? Beautiful. What's the next one I could do?
1 over 3.
And which actually equals that. So, therefore, the common ratio is? Beautiful. Therefore, common ratio, or R, I could have just written R, sorry, whoops, is 1/3. Therefore, it's geometric. This is the kind of question where you might get a method mark. Oops, sorry. So now, girls, here, I don't like the fact that I've just got 1 on 3 sitting there. Maybe I should have done U3 over U2, is that? And I could have even done here U2 over U1, just to explain what I'm doing. Does that make any sense? So, girls, with marking, this is the kind of thing you might get a method mark for and maybe a R mark for reasoning. Does that make sense? I want to make sure it's logical. Okay, B. Find the nth term, or we could have said general term, or even the rule. Can anyone help me out? So what are we talking about? What do I want to find? I've already found R. R is a third. UN, very good. So let's write down the rule. UN is U1 times R to the n minus 1. So let's have a go. What does that become for this particular example? 9. A third to the... Beautiful. Now, girls, technically, that's fine. But can we just try to simplify it a little? Okay, is that all right? Girls, I'm just going to leave the 9 as it is. What if I want to... what's that dot mean?
Times.
It actually means times, yes. Are we okay with that? If you're not okay, you can always do the cross. Now, 1 on 3 to the n minus 1, I want to get rid of the brackets. So how else could I write that? Good, okay, good. Lily, what are your thoughts?
Can you do it 3 to the n minus 2?
Close, but rather than get rid of the fraction, let's leave the fraction there, just to make it easy. I just want to get rid of the brackets. Yes, Lisa?
Could you make the 1/3 actually 3 over power negative 1?
No. Don't get rid of the fraction. I like the fraction. Get rid of the brackets. Okay, Alicia?
We get the power to just expand it into the fraction.
Exactly. What does that become?
Is it just 1 over 3?
Take a moment, girls. Why is that correct? Very good. Take a moment. Why don't I have 1 to the n minus 1, or why don't I need to? 1 to the power of anything is just 1. Is that okay? 1 to the 56, 1. 1 to the negative 3, 1. Is everyone okay?
Yeah.
1 to the 0, 1. Okay? So I only really need to write it down as 1 over 3 to the n minus 1. I'd like to go a little further with it. Technically, you don't have to. You could have stopped here, but I want to practice our index laws, and this kind of thing will be used to in harder problems, okay? So I could write that all as just one fraction, as something over something. What does that whole thing become? 9 over? Beautiful. But wait a minute, I can rewrite 9 with base 3. What can I do there? Can anyone help me out, Roxy? 3 squared over 3 to the n minus 1. Wait a minute, I have 2 terms with the same base. How could I rewrite that as just 3 to the something? Take a moment. What's my new power of 3, or how do I get it? Yes?
You minus it?
Mm.
To n minus 1.
Yep, so it'd be 2, 2 minus, and I'm going to put it in brackets so I don't make a silly mistake. Is everyone okay? It's 3 to the 2 minus n minus 1. How you doing? Is everyone okay?
Yeah.
Okay, so can someone expand and simplify that power? Take a moment, take your time, because I want you to try and be careful. If you need to write it out, that's fine. What is my new power? Hands up, okay? Check it. Rhiannon,
I checked it, but I'm still
just say it.
Is it 3 minus n?
Yes! Okay, let's talk about that. Negative n, just negative n. Oh, sorry. Oh, it only comes up on my screen? No. So, expanding this, negative 1 times n is negative n. Negative 1 times negative 1 is positive 1. So, 2 plus 1 is 3. How you doing? So, girls, I I know not all of that was necessary for this question, but being able to do that is going to benefit you in some questions, some harder style questions. Is everyone okay? Beautiful. Now, C, after all that, let's actually get to C. Find the 15th term of the sequence. How do I do that? What's 15? Sub
15 as n.
Beautiful. So I want to find U15. Now, you will get the right answer if you put it into this one, or this last one, whatever you want. Technically, even if you have a calculator, the benefit of this last one is that it's just slightly easier to put in your calculator. You know what I mean? So like this will become 3 to the 3 minus 15, which is technically 3 to the negative 12. And if it was a paper one, I'd leave it like that because I don't have a calculator. Is everyone okay? But what is that on your calculator?
Do you want me to make it scientific notation?
Oh, okay. How about we just go 1 over 3 to the 12? Or, okay, what do you get in scientific notation?
1.8. Wait, no. 1.9.
If I want 3 significant figures, what would you do?
8
1.88
times 10 to the 6.
Negative 6, you mean?
Negative 6.
Negative 6, because it's a small number. Beautiful. That would be correct. That would be correct. When you have it as a fraction, is it something you can write down, or does it go on forever? Like, what does it do when it is a fraction? What's 3 to the 12? Like, is it huge?
Oh, just 3 to the 12.
It's 1 over 50.
It's
Just
531,400.
yeah.
So you could write that too. You could write that fraction. You could write it as 3 to the 12, or you could write it in scientific notation. At least 3 significant figures when you do scientific notation. Is everyone okay? So any of those would be correct. And if you put 15 into this one back here, you should get the same thing as well. Is everyone okay? Beautiful. I just realized there's a mistake in this question. Can we please make this a plus and this a plus? Can everyone do that right now? And now let's do it. So, the consecutive terms in a geometric sequence, that must mean there's a common ratio. So how can we create an equation? What would we do?
6k over k plus 2.
Yes, it should equal?
38 plus k over 6.
Beautiful. So, first let's solve it algebraically as if it was a paper 1. Girls, we're cross-multiplying. Watch this, because some people were confused. You do 6k times 6k, and then k plus 2 times 38 plus k. The denominators are actually moving to become multipliers of the other side. Okay, so what does that become? 6k times 6k is 36k squared. And then k plus 2 times 38 plus k, let's write it out first. And that's why what happens, yes? They don't disappear, they're moving to the other side and becoming multiplication. They're not disappearing. Another way to think of it is this. Girls, no, stop. I'm explaining it. Another way to think of this, it is this. Girls, if you had an equation like this, x on 3 equals 5x on 2. Another way to think of it is this. You might have heard me say, multiply everything by all the denominators. Do you remember that? I used to explain it that way last year. So, you can think of it as timesing both sides by 3 and 2. Timesing both sides by 3 and 2. What happens on this side? What cancels out? The 3 and the 3. So then I am doing 2 times x, which is 2x. Does that make some sense? What's cancelling out on the other side? The 2 and the 2. So 3 times 5x is 15x. Okay, so let's use that method on our other one. Okay, so that would mean multiplying both sides by, what are my two denominators? 6k and k plus 2. And I do that over here, 6k and k plus 2. Oopsie. What cancels out on this side? K plus 2, which is why this side is 6k times 6k, which is 36k squared. Does that make more sense? On the other side, what cancels out? 6k and 6k, which is why I'm left with 38 plus k times k plus 2. So whichever way you like it, cross multiplication or multiplying everything by all the denominators, it's whatever you prefer. But remember, girls, if I add a 1 over here, add an extra term that's outside the fractions, I can't really do cross multiplication anymore. That's when I have to times everything by all the denominators. So that's just a little reminder there. Okay. Now anyway, let's keep going. Let's expand. So I've just got 36k squared over here equals
38k plus 76.
Sorry, yes, you're right.
You wrote 88.
I don't know, what did you say the first time? 30, okay. 38k.
And then plus k squared
Yes,
plus 2k.
beautiful. Actually, I'm not sure that this will work, but let's just...
Do you want the next?
Oh no, I think it will. Everything's okay. Now, let's move everything over to where k squared is positive. Is everyone cool with that? So, 35, oops, yeah, that's right, 35k squared. What else do I have?
Minus 40k.
Minus 40k.
Minus 76.
Good. Now, girls, I might just ask you, think about the discriminant. I'm just going to put this on the side. Because for me to check if there's a solution, I need to think about the discriminant. Do you remember that in quadratics? How did I know? Just by looking at it, this will have a solution. Or in other words, it'll be bigger or equal to 0, or bigger than actually. I don't even work any calculations out in my head. I'm not working a thing out. Just by looking at this equation, just by looking, checking one little thing, I know that b squared minus 4ac is going to be bigger than 0. Take a moment. Think about where all the numbers go. How do I know? Just by looking at it. I don't even work anything out. We got some hands. Oh, excellent. Okay, let's see what you have got to offer. Rihanna, what do you think?
Oh, I was going to say C is negative.
The C is negative. So girls, look what happens. B squared is 40 squared, which is 1600, minus 4 times 35 is some big positive number, times a negative number becomes a negative number, but if it's minus a negative number, it's going to be plus. And therefore the discriminant is going to be positive, and therefore everything's going to be 5 and there is going to be a solution. Is everyone okay? All right. Now, after all that, girls, they're pretty ugly numbers. I don't want to do it algebraically. What could you use on your calculator to solve that? And solve or polyroots. Have you ever used that?
Yeah, it does this sort of quadratic.
Yeah, it solves the quadratic for you. Let me show you. Let's do it together. So k is negative, using polyroots, negative 1.009, and what was the other one? 2.15. Now here's the thing.
Do you have to check which one will work?
Actually, they both will. Unless they had said k is bigger than 0, or all the terms, if they had given us more information like k is bigger than 0, or all the terms in the sequence are positive, in which case, if you check, your k couldn't be negative 1, then you'd say, oh, therefore k is 2.15. Because they didn't give us any information, any other information, k could be either of those. So you could include either of those. Is that okay?
Yes, you're right.
So,
We have to write a little sentence there.
oh no, they said find k equals
Can
done.
you leave it as that?
Yeah, girls, if they had said if they had said find the 3 terms, then we'd probably have to sub that back in. But they've just said find k, and we've literally said k equals. That's fine. Amy?
When you're putting the answer like k equals that, do you have to do the same significant figures? For both of them?
No, always at least 3. And that's always the rule. As long as you do both at least 3, even if it's not the same number, that's fine. The only reason I did negative 1.009 just because I could have done negative 1.01, and that's fine. Just because of I don't know. I just did it. Anyway, is everyone okay? And so, back to what we were saying before, we used polyroots to solve that. In a paper 2, you could have also done N solve. Let me show you one thing, but you also could have done N solve, which should work now. Let me show you. So we're finished now. Wait. Oh no, we're not finished. Ha ha ha. We'll finish it next lesson and then do work. So you might be able to start 60.1 tonight, but we'll finish the theory tomorrow or next lesson, whenever that is.